Now we're going to go over another concept of trigonometric identities. So a little info from 4.3. In the textbook it says, recall from lesson 4-3 that trigonometric functions can be defined on a unit circle as shown on the right here. Notice that for any angle theta, sine and cosine are the directed lengths of the legs of a right triangle with hypotenuse of 1. So the hypotenuse of 1, sine theta, the vertical line, and cosine theta, the horizontal line. Continue on, we can apply the Pythagorean Theorem, meaning x squared, y squared, and r squared, to this right triangle to establish another basic trigonometric identity. So instead of x, it's sine theta. Instead of y, it's sine theta, and instead of x, it's cosine theta, and instead of r, it's 1. So what it's saying is sine theta squared plus cosine theta squared equal to 1 squared. That's the Pythagorean theorem. When you simplify, it's sine squared theta plus cosine squared theta equal 1. That's going to be another trigonometric identity. While the signs of these directed lengths may change depending on the quadrant in which the triangle lies, notice that because these lengths are squared, the equation above holds true for any value of theta. This equation is one of the 3 Pythagorean identities. So what it's saying is, regardless of what quadrant it is, if the angle theta for sine or cosine is negative or positive, when you square it, it's just going to come out positive. That's why it ties into what we did in 4.3, where I always said that r is always positive. When you square x and y, even though it's negative, it's going to become a positive number. And then when you simplify, when you find the square root, it's always going to be a positive number for r. So that's what it's basically saying, regardless of what quadrant it is, regardless of what angle it is for sine and cosine, when you do the square of it, you'll get a positive value. Now, moving on to these Pythagorean identities, which you should have in your notes, which also you should know by heart, especially when it's going to be on a quiz and on a test. So the first one, sine squared theta plus cosine squared theta equals 1. The same could be said for cosine squared theta plus sine squared theta equals 1. The order does not matter. Same thing here. Tangent squared theta plus 1 equal to secant squared theta. Same thing if 1 plus tangent squared theta equals secant squared theta. Cotangent squared theta plus 1 equal cosecant squared theta. Same could be 1 plus cotangent squared theta equal cosecant squared theta. So again, know these 3 trigonometric identities by heart, and it should be in your notes. And then a little information at the end. Notice that shorthand notation used to represent powers of trigonometric function, sine squared theta is the same as sine theta squared. Cosine squared theta is the same as cosine theta squared. Tangent squared theta is the same as tangent theta squared, and so on. So when you see these, if it's either sine squared theta or sine theta squared, doesn't matter, it's still the same thing. It means the same thing. So it's okay if the square is in the inside, just like the one on the left, or if the square is on the outside of the parenthesis, just like the one on the right. It still means the same thing, just different looks, different notation. That's all it is.